Assalamu alaikum and welcome to Cambridge Chemistry channel. Be sure to like the video and subscribe this. Really help the channel to grow. In this video I will discuss the question regarding enthalpy change of the solution. You are to determine the enthalpy change of solution. Enthalpy change of solution in kilojoule per mole of ammonium chloride. Fb3 is approximately 9 gram solid of ammonium chloride in distilled water. Method: read through the instructions carefully and prepare a table below for your results before. To draw the table is also very important in enthalpy change question. Before starting any practical work, weigh the plastic cup and record the balance reading. Add between 2.9 and 3.1 gram of ammonium chloride Fb3. Fb3 is the ammonium chloride, and record the new balance reading. Place the plastic cup in the 250 centimeter cube and it is transferred this in 250 centimeter cube beaker. Pour 25 centimeter cube distilled water into the measuring cylinder. So add 225 centimeter cube of distilled water. Place the thermometer in the water, thermometer like this in the water, and stir with the thermometer the solution and record the initial temperature in the table of the results. Pour the 25 centimeter cube of distilled water into the plastic cup. Now stir the content of the cup and record the lowest temperature of the solution. Tilt the cup if necessary to ensure the thermometer bulb is fully immersed. Repeat the procedure using the other plastic cup. Use between 4.9 and 5.1 gram of Fb3 for this experiment. Record the mass of Fb3 used and the change in the temperature for each experiment. So these are the two experiments which you are doing according to this paper. Mass of, so draw the table like this. Mass of plastic cup in grams. Always write down the unit along with the quantity. Experiment number 1, this is the mass of plastic cup. Experiment number 2, mass of plastic cup plus Fb3. So this is mass of cup plus ammonium chloride solid. Fb3 is ammonium chloride 5.14 and this mass is 7.14. Mass of Fb3 used in both experiments 3 gram and 5 gram. Initial temperature, always write down the unit, degree centigrade. Final temperature, degree centigrade. So initial temperature of experiment 1 is the 28 degree centigrade and 3 significant figure. Always write down the 3 significant figures for mass and for temperature. 20.0, 15.0 change in temperature. So the difference of these two temperature is initial from final is 8 degrees centigrade, and this is for experiment 2 this is 13 degrees centigrade. So if you draw the table and write down the your readings accordingly, then you will straight away get these marks. Five marks. So now calculate the mean mass of Fb3 used. Give your answer to 2 decimal place. 2 decimal place. Always write down, follow the instructions given in the question. 3 plus 5 divided by 2. So this is the 4 gram. Calculate the mean temperature change. Give your answer to 1 decimal place. So this is the difference of this temperature 8 and difference in this and mean is 8 plus 13 over 2 is equal to 10.5 degrees centigrade. Mean temperature change is 10.5 degrees centigrade. Calculation shows your working and appropriate significant figures. Show your working and appropriate significant figures in the final answer of to each step of your calculations. Always use 3 to 4 significant figures in while writing the answer. Calculate the number of moles of ammonium chloride present in the mass of FB3 calculated in B1. So this is mass is 4. We have 4 gram is the mean mass of 2 experiment. So 53.5 is the MR of ammonium chloride. Nitrogen is 14, hydrogen is 4 plus chlorine 35.5. So this is equal to 53.5. So the answer is 0.0748. So this is the answer. Use your answer to B2 and C1 to calculate the enthalpy change of solution in kilojoule per mole of ammonium chloride. Assume that 4.2 joule of heat energy changes the temperature of 1 centimeter cube of solution by 1 degree centigrade. So write down the formula. Q is equal to mc delta T. We use 25 centimeter cube of distilled water to dissolve ammonium chloride. So always write down the volume is equal to mass in Q is equal to mc delta T. Volume is equal to mass. So volume cm cube is equal to gram. If you are using 25 centimeter cube of distilled water, it is 25 equal to 25 gram. So mc delta 25 into 4.2 into 4.2 is the specific heat capacity, C is the delta T is the temperature change. So this is the answer, 1103 joules. So answer should be in kilojoule because delta H unit is kilojoule per mole. So convert into kilojoule by dividing the 1103 divided by 1000. So this is equal to 1.10 kilojoule. So 0.0748 releasing 1.10 kilojoule energy. 1 mole is equal to X. So this is 14.7 kilojoule. You can write down now according to the new syllabus. This is the formula of delta H. You are using like this. Delta H is equal to Q divided by mole. Q is equal to 1.10 divided by mole is 0.0748. The answer is 14.7 kilojoule. Enthalpy change is positive because dissolving of the sign dissolving of ammonium chloride is endothermic, and you can get the sign over here, in the temperature change. Initial temperature is 28 while final temperature is lower. If temperature is going to decrease, then the reaction is endothermic, positive delta H. So in both cases 28.5 and over here 15.5. In both cases the temperature change is temperature is going to decrease during the experiment, so the reaction is endothermic. So dissolving of ammonium chloride is endothermic. When which of the two experiments in A, the first or the second, had the greater percentage error in the value calculated for the temperature change? Temperature change for experiment 1. Given that the error in single thermometer reading is 0.5 degrees centigrade, calculate the percentage error in the temperature change for the experiment you gave in D1. So 0.5 is the error in a single thermometer, 0.5 into 2, while because you are measuring initial and final temperature, so multiplied by 2 times you are taking the temperature, so that's why into 2. So this is the change in temperature divided by 8 into 100. So percentage error is equal to error divided by value which you are using, the temperature change, that is value into 100. So 12.5% is the percentage error. A student suggested that it would have been better to calculate the enthalpy change for each experiment separately. What would be the advantage of this suggestion? Explain your answer fully. To check whether further experiments should be carried out, or to find out whether mass added is proportional to delta T, or to compare the two answers. So we can write down to check whether further experiments should be carried out, or you can write down to find out whether mass added is proportional to delta T. That if mass is directly proportional to delta T, by increasing mass delta T is increasing. Some more temperature change, or to compare the two answers. Another student suggested that the procedure would be improved by covering the plastic cup with a lid. Explain whether this would improve the procedure. No improvement as temperature drops, so no heat loss as reaction is endothermic. So this is the, according to this, this should be answer. No improvement as because temperature drops, so no heat loss as reaction is endothermic. Or you can write down improvement as to prevent heat given from the surrounding if the reaction is exothermic. So hopefully you got it.